Welcome back to another session, my dear students. Okay, so we can directly move on to the questions. Okay, so you can see the question. The two vectors, the vectors is given that I cap plus j cap plus k cap and I cap plus 3j cap plus 5k cap represent two sides AB vector and AC vector respectively of triangle ABC. Triangle ABC. The length of the median through A is. We need to find the length of the median through A. Okay, so it's given that the two vectors. So it's given I cap plus j cap plus k cap, I cap plus j cap plus k cap, and the next is I cap plus 3j cap plus 5k cap. Okay, so this represent the two sides of a triangle. So two sides. So that is, we can represent this AB vector, and this one as AC vector, respectively of triangle ABC. And we need to find the length of the median through A. So for this question, we need to find the length of the median through A. So first of all, we can draw a triangle. Yes, we can draw a triangle like this. Okay, so for this triangle, we can consider this one as A, B, and this is C. Okay, this is A, B, C. And hereafter, AB, from AB vector, we can write AB vector is equal to, AB vector, from this we can write AB vector is equal to 1, 1, 1. Okay, and AC vector is equal to 1, 3, 5. AC vector, so that will be equal to 1, 3, 5. So hereafter we can find BC vector. Okay, so it's already mentioned in the question. What is that? Yes. So the length of the median through A. So this is the median through A. Okay, so we can represent this point as D. Okay, so hereafter we can find BC. So BC vector will be equal to AC vector minus AC vector. Yes, AC vector. So this minus AB vector. Okay, so that is, we will get the point like BC vector is equal to 0, 2, 4. We got the point 0, 2, 4 for BC vector. Okay, so here, since D is the midpoint, okay, you can see D is the midpoint of the vector BC. So for BD, D is the midpoint of BC. Okay, so from here we can write BD vector is equal to BD vector. So that is equal to half of this, isn't it? So because this is BC, this is A. Okay, so BD is equal to half of BC. BD is equal to half of BC. So BD vector is equal to, we can write BD vector, that is equal to 0, 1, 2. Half of this. So 0 by 2, 2 by 2, 4 by 2. Okay, so that is equal to 0, 1, 2. BD vector is equal to 0, 1, 2. So hereafter the next is AD vector. So AD vector, that will be equal to, look at here, AD vector is equal to AB vector plus BD vector. Okay, so if you are going to add this, we get the points AD. Yes, AD will be equal to AB plus BD. So this is BD, and we know that AB is equal to AB. AB is equal to, let me write here, AB is equal to 1, 1, 1. 1, 1, 1. Okay, so AB plus BD. So that is 1, 2, 1, 2, and the next is 3. So AD vector is equal to 1, 2, 3. We got the point 1, 2, 3. So hereafter, on the next we can find the modulus. Okay, so the modulus of AD vector. The modulus of AD. Okay, so the modulus of AD is given as. Okay, so modulus means root of 1 square plus 2 square plus 3 square. 1 square plus 2 square plus 3 square. So that is equal to 1 square plus 2 square plus 3 square. So that is 1 plus 4 plus 9. 1 plus 4 plus 9. So the answer is, the final answer is root 14 is the final answer. Root 14 is the final answer. Okay, so for this question, for this one, option A is the correct answer. Option A is the correct answer. That means root 14, root of 14. Root 14 is the correct answer for this question. We can move to the next. So the question is that if A and B, that is A vector and B vector, are unit vectors and theta is the angle between A vector and B vector, then we need to find sine theta by 2. So for this question, we need to find sine theta by 2. So how we can find sine theta by 2? Sine theta by 2. We need to find this. So it's given that A vector and B vector are unit vectors. B vector are unit vectors. Unit vectors. Already given this question. Okay, and here theta is the angle between A and B. Theta, angle between A and B. Angle between A vector and B vector. A vector and B vector. Okay, so hereafter we can write modulus of A vector minus B vector the whole square. So that is equal to, we know that is equal to modulus of A vector all square plus modulus of B vector all square minus 2 into modulus of A vector into modulus of B vector cos theta. Yes, we can put this one in a box. Cos theta. Cos theta. Okay, so that is modulus of A vector minus B vector the whole square is equal to modulus of A vector. Yes, modulus of A vector plus modulus of B vector minus 2 into modulus of A vector into modulus of B vector cos theta. So hereafter we can write A vector, B vector. It's already mentioned they are unit vectors. So modulus of A vector and modulus of B vectors. What is the value? Modulus of B vector. So that is both are equal to 1. So hereafter for this modulus of A vector and modulus of B vector we can substitute 1. So while we are substituting here, we got 1 plus 1. 1 plus 1. So that is 2. We can write 2 minus modulus of A and modulus of, yes, modulus of A vector and modulus of B vector. So what is the value? This is 1. So 1 into 1 means 2. Sorry, 1 into 1, that is 1. And that 1 into 2 here. So it is 2 into cos theta. So that means modulus of A vector minus B vector, the all square is equal to 2 minus 2 cos theta. 2 minus 2 cos, yes, 2 minus 2 cos theta. So hereafter we can take 2 common outside. Look at the last step. You can see that 2 is common there. Here 2 is common there, so we can take 2 outside, common outside. So that is, the right hand side becomes 2 into, we can take 2 common outside, 2 into 1 minus cos theta. 2 into 1 minus cos theta. Okay. So here the right hand side is A vector minus B vector. A vector minus B vector all square. So that is 2 into 1 minus cos theta. What is 2 in 1 minus cos theta? 1 minus cos theta means we can write it as 1 minus cos theta. Here 1 minus cos theta. For this one, we can substitute that is equal to 2 sine square theta by 2. 2 sine square theta by 2. Okay. So in the next step, we can substitute this value. Instead of 1 minus cos theta, we can substitute 2 sine square theta by 2. So it will become modulus of a vector minus b vector, the all square is equal to 2 into 2 sine square theta by 2. 2 sine square theta by 2. So that means sine theta by 2 is equal to modulus of a vector minus b vector divided by 2. Yes. Now look at the options. There are 4 options there, right? So here for this question, option D is the correct answer for this one. Okay. So option D is the correct answer. Now let us move on to the next question. So the next question is given that, yes, the curve passing through the points is given that the curve passing through the point 1, 2, given that the slope of the tangent at any point xy is 2x by y represents. The question is that whether it is a hyperbola, that is the first option, second is circle, or whether it is a parabola and ellipse. So you can see there are 4 options there. The curve passing through the points 1, 2. Curve passing through the points 1, 2. Given that the slope of the tangent at any point xy, is 2x by y. So this is a question. So we need to find whether it is a hyperbola or circle or parabola or ellipse. Okay. So first of all, from the given question, we can write dy by dx. That is equal to dy by dx is equal to 2x divided by y. dy by dx is equal to 2x divided by y. Yes, slope of the tangent at any point, isn't it? Because slope of the tangent at any point is given as 2x by y. We know that slope of the tangent is dy by dx. So we can write dy by dx is equal to 2x by y. Yes, so hereafter just interchange this. Okay, so on the left side it will become y dy, and on the right side it will become 2x dx. 2x dx. So hereafter take integral on the both sides. So it will become integral of y dy is equal to integral of 2x dx. Okay, so on the left side it will become integral of y dy is equal to, on the right side that is integral of y dy is equal to integral of 2x dx. So hereafter we can integrate this. So on integrating y dy, we will get, on integrating y dy, we will get y square by 2, isn't it? So y square by 2 is equal to here 2x dx. 2x dx means x square. Yes, 2x square by 2 into, you can see there is a 2 into 2. So we can cancel this. Plus, yeah, so what is here? A means where A is a constant, So now look at here. From this, simply we can write the last equations. Let me write the last equation once again. So the last equation is y square by 2 is equal to x square plus a. Y square by 2 is equal to x square plus a. Okay. So from this, simply we can identify that this above equation represent a hyperbola. So this one represent a hyperbola. represent a hyperbola. Okay, so for this question, the correct answer is option A is the correct answer. That is, hyperbola is the answer for this one. Hyperbola is the answer. Okay, so the question is that it's given if modulus of A vector cross B vector the whole square plus modulus of A vector dot B vector the whole square is equal to 144. The value is given as 144 and modulus of A vector is equal to 6. Then we need to find modulus of B vector. We need to find the value of modulus of B vector. Okay, so it's given that. It's given, first of all, we can write modulus of A vector cross modulus of A vector cross B vector. The all square is equal to, plus modulus of A vector dot B vector, the all square is equal to 144. And it's given modulus of A vector, the value is given as 6. We need to find modulus of B vector. We need to find the modulus of B vector. Okay, first of all, we can consider this. We can consider the left hand side. This is the LHS. We can consider the LHS. Okay, so for LHS, this is the left hand side, that is LHS. So for LHS, we can write it as modulus of A vector the all square into modulus of B vector the all square. Okay, so here it is cross product. So here it is cross product. That means modulus of A vector cross B vector the whole square, that is equal to modulus of A vector all square into modulus of B vector all square into sine theta plus, and for this one modulus of A vector dots, here it is cross product, so sine theta is here, and here it is dot product, so cos theta is here. So that is modulus of A vector the all square into modulus of B vector the all square into B vector the all square cos square theta, and the right hand side the same, the RHS same, that is equal to 144. RHS that is equal to 144. Okay, now look at here. You can see this term is common for both. Modulus of A vector the whole square into modulus of B vector the whole square, that is common, so we can take it outside. So while we are taking this outside, what is the remaining one? There is one mistake. Okay, so here it is sine square theta and then it is cos square theta. Okay, yes. So on the next step we can write, we can take modulus of A vector all square into modulus of B vector all square. We can take this common outside. So the remaining one is sine square theta plus cos square theta. So what is sine square theta plus cos square theta? The value is equal to, value of this is equal to 1. So hereafter we are going to substitute sine square theta plus cos square theta, that is equal to 1. And the right, what about the RHS? RHS is equal to the same 144. So this is equal to 144. Is equal to 144. Okay. So on the next step, we can write modulus of A vector the all square, modulus of A vector the all square into modulus of B vector the all square is equal to RHS 144, because the value of this is equal to 1. So hereafter we can write modulus of A. The value of modulus of A vector is already given in this question. So the value is equal to, yes. So the value is equal to 6. So for this one, the value is equal to 6. So here, what is this? 6 square. 6 square means 36. Okay. So this is 36 into modulus of B vector. B vector the whole square. Yes. Modulus of B vector the whole square is equal to 144. So hereafter, on the next, what is the next step? Modulus of B vector the whole square is equal to 144 divided by 36. 144 divided by 36. Yes, this is the second last step. Okay, so in the question they are asking us to find modulus of B vector. So in the next step we can consider the RHS. Okay, yes. So for the next step we can write modulus of B vector. Modulus of B vector is equal to 144 divided by 36. What is the value? 144 divided by 36. So, okay, for this one, if you are going to divide 144 divided by 36, 144 divided by 36, we will get the answer 4. Okay, so modulus of b vector all square is equal to 4. Therefore, modulus of b vector is equal to modulus of b vector is equal to square root of 4. So, the value is equal to 2. Okay, so for this question, option D is the correct answer. That means here 2 is the correct answer. The modulus of b vector, yes, modulus of b vector is equal to modulus of b vector, so that is equal to 2 for this question. So the question is that, easy question, the point 1 minus 3, 4 lies in the octant. It's already given the point 1 minus 3, 4 lies in the octant. Okay, yes. So you can see it's given the point 1 minus 3, 4 lies in the octant. Okay, so which one? We need to select. The first option is 8, second option is second, third one is third, fourth one is fourth. That means option A is equal to 8, option B is equal to second, option C is equal to third, option D is equal to fourth. Okay, now look at here. We can consider the first, okay, the first one, option A. For the first one, 8. For 8th quadrant, we know that this is X, Y, Z. Okay, for the 8th quadrant, if you are just considering the 8th, okay, for 8th, we can write X is positive, Y is negative, and Z is negative. Okay, for 8th quadrant, X is positive, Y is negative. So simply we can write for a 8th quadrant, X, Y, Z. So that means positive, negative. So this is for the 8th quadrant. And for the second quadrant, okay, for the second one, X, Y, Z, the value of X, Y, Z is equal to, you can see, minus, plus. So this is for the second quadrant, the value is minus, plus, positive. So hereafter, we can consider the third one. Okay. So what about the third? For the third one, X, Y, Z is equal to, the values are X is negative, Y is negative, and Z is positive. Okay, for the 8th quadrant, X is positive, Y is negative, Z is negative, and for the second quadrant, X is negative and Y is positive and Z is positive, and for the third quadrant, X is negative, Y is negative, and Z is positive. And what about the fourth quadrant? For the fourth quadrant, we can see that, yes, what about the values of X, Y, Z? You can see value of X is positive and Y is negative and Z is positive. Okay, now we can again back to the question. So the question is that the point, in the question it's given that point 1 minus 3, 4, that lie on which quadrant? Just look at here. Here value of X is positive, Y is negative, Z is positive. Okay, so for this question, the correct answer is option D is the correct answer. That means this point lies in the fourth quadrant. Okay, so option D is the correct answer. Option D is the correct answer for this one. Okay, if the vector, it's given that if the vector 2i cap, so the next question, if the vector 2i cap plus 3j cap, okay, sorry, 2i cap minus 3j cap, 2i cap minus 3j cap plus 4k cap, and the next vector is given as 2i cap plus j cap minus k cap. Okay, and the next is given as lambda I vector minus, lambda I cap, it's not vector, lambda I cap minus j cap plus 2k cap. plus 2k cap. It's given that are coplanar, then the value of lambda. It's given that are coplanar are coplanar and the value of lambda. We need to find the value of lambda. We need to find the value of lambda here. Okay, look at here. The value of lambda. We need to find the value of this. Okay. For this question, it's given that they are coplanar. Okay, in the question itself, it's given that the three vectors, 1, 2, 3, three vectors are there coplanar. So what is coplanar? Coplanar means vector lie on the same plane is known as coplanar. Okay, so for this one, the determinant value is 0. Determinant of this is equal to 0. So hereafter, we can write the determinant on the next step. Okay, yes. So the determinant of this. So determinant value for the first, from the first vector, we can write 2 minus 3, 4, and for the second one we can write 2, 1, minus 1, and for the third one we can write lambda minus 1, 2, that is equal to 0. Why it is equal to 0? Because in the question itself it's already given that it's in lines on a coplanar. The three vectors are coplanar, means they lie on a same plane. So this is equal to 0. So hereafter we can find the determinant value. So the determinant value is 2 into, yes, 2 into 1. If you are just finding the determinant value, 2 into 1 plus 3 into 4 plus lambda plus the next is 4 into minus 2 minus lambda is equal to 0. Minus 2, this is minus 2 minus lambda is equal to 0 because it's in coplanar, so the RHS will be equal to 0. So on the next step, just simplify this. So that is, for the first one, we can write that is 2 plus, yes, just open this. So if you are going to open this, 3 into 4, 12 plus 3 lambda, 4 into minus 2, minus 8. So 4 into minus lambda, minus 4 lambda is equal to 0. Okay, so now look at here. 3 lambda minus 4 lambda. So what is that? That is equal to 3 lambda minus lambda, isn't it? Yes. Now look at here. 12 plus 2. That is 12 plus 2 is 14. Okay, 12 plus 2 is 40, 4. So 40 minus 8. 40 minus 8 is equal to 6. So 6 minus lambda is equal to 0. So hereafter we can write lambda is equal to, the value of lambda is equal to 6. Okay, so the value of lambda, that is equal to 6. Okay, so for this question, for this one, the correct answer is option B is the correct answer. That means the value of lambda is equal to 6. So option B is the correct answer for this question. Okay.